Yeah, the question is replace with first. The question say that we are given two string S and T and their size are respectively N and M. And we can do one operation, that is if a string is given ABC, then we take a substring and we can replace the substring with its first character. In this case, the substring is CABC. Then we can replace with its first character, that is C. So, what we have to do, we have to make the given string S and T to equal in one of in minimum operation. So our goal is to make the two string equal by doing operation. The operation is that we have to take the substring and we can replace the substring with its first character. So the input format. In the first line, we have to given T, where T is the number of test cases. And for each T, the first line for each T, the first line we have given N or M. And the second line, we have given string S of will be size N, and in the third line, for each test case, we are given the string T or T will be of size N. And what will be our output format? Output format. So for each test case, we have to return one thing, that is mean number of operation. If it is not possible to make a string equal, then return -1. Now let us consider about constraint. So we have given the constraint, the number of test cases T or test cases lies between 1 to 10 raised to 5. The N or M, where N or M is the size of a string, it will lie into 1 to 2 into 10 to the power 5. And third thing is S and T string will be in lower case. And it is also given that sum of n won't exceed 2 into 10 to the power 5, and sum of m would not exceed 2 into 10 to the power 5. So we have given the sample test cases. Here first line will be T, number of test cases, and the second line will give a N or M. Here N or M, let's say 4 and 3. And the second line of the first test case is S equal to A, B, C, and let T equal to A, B. Then what will be the minimum number of operations to make this equal? If S equal to T, then we have to don't do anything because it is already equal. So mean operation will be 0. And what will the max operation? The max operation we can do it is, suppose to string whatever it is given, we can take the whole string as a substring. If it is first character is matching, then we can make it as one, replace all the string with one with his first character, and replace all the string with its first character. So for replacing all the string a b c d with his first character, it became a, and for the replacing all the character of the t with his first character a b c m e f, it become a. So in this we require two operations. For any test case, if the first character is matching, then max operation we can do, in which we make the string equal, that is 2. That is, we will replace all the string with its first character and replace all the string with its first character. So max operation that is required is 2. But what if its first character is not matching? Let's say example M N A F and T and A F. All the string is matching, but its first character is not matching. By hook and crook, we all the operation we can apply, but if the first character is not matching, then we can't make the first character M equal to T, because to make we can't delete this. We have to only replace the character of substring, the first character. So by doing anything, we can't make M equal to T. So if first character is not matching, then we can't make a string S and T equal. If a first character not match. So if the first character not match, then we have what we will have to return. The question it is stated that we have to return 1, -1. So our output will lie in -1, 0, 1, 2. So till now we have observed that if S equal to T, then we don't require do any operation because it is already equal. So the mean operation will be 0. If character doesn't match, first character doesn't match, then we can't make it equal by any hook and crook. So we have to return -1. That is, can't make equal. And max operation we can do is 2. That is a. So now let's discuss the test case A, B, C, D, E, F, and A, B, C, E, F. Let's say there is O. Now let's discuss this thing. Here N is greater than M. So we are observing a pattern that a prefix is matching. There is any character in between that lies, and suffix. Prefix and suffix. So in this, prefix is matching, suffix is matching, and there is anything which lies in between. So in the test case we have which we have taken A, B, C, D, E, F, and A, B, C, E, F. This is matching, this is matching, E, F is matching, E, F is matching. Then what we can do? Mean operation to make this equal, and this is ending. anything which lies in middle. Then what we can do, min operation to make this equal. So take the string COD and we can replace COD with its first character, that is C, and A, B, C, E, F. So in the one operation, because we are only applying operation in string one, string s, so we are doing one operation, and in one operation where there is a pattern like prefix is matching and suffix is matching, and in middle it is not matching, that in one operation that we are applying the last longest string, and we are able to make these two string equal. So what we are observing is the left common substring and right common substring length of left common substring plus length of right common substring, it will be equal to 0. It will be equal to the length of a string t, that is mean length in between. It will be equal to length of mean substring, or it will be greater. Why it will be greater? Suppose ABC and ABC. Suppose at max what will happen if we are checking first if equal to 0, that will return, but it is not matching. If suppose this is not matching, then from it will traverse all the from left to right or from right to left. At max at possible, then it will traverse from left to right and from right to left. Then it may happen that length of left common substring and length of right common substring is greater than the mean length of this string. So this is the condition when we have to return 1, or if the above condition doesn't satisfied, then what will then we have checked for 0, we have checked for -1, we have checked for 1. Then at max operation that lies is we have to convert both the string. We have to apply a operation both the string, and both the string, whatever we do at max, suppose simple, we can make it take the longest, take the string as a substring, and may take replace with the first character, and in this we can replace the first character. So we at max operation that we are doing is 2. So now let's convert our main logic based on observation into pseudocode. So in this, first we are taking input t, and we will loop over the test cases t, and in the first line we have to take in the first line we have to take n or m, where n is the size of string s and m is the size of string t. In the second line we have to input string s. In the third line we have to take input string t. Now apply our logic. If s equal to t, then we will print min operation, and min operation will be here 0. else the first character of the two string doesn't match, then it is not possible to make a string. So we'll print -1, and it is given that our n or m is always greater than equal to m. It is given in the test constraint. So we can compare s of 0. And what if? Now we'll check if n is greater than m or equal to m. Now we'll check for the our we have to test we have a write the condition for 1 0. Now we'll write the condition for 1 or 2. So in this, let's see out our is possible. In this we will apply the condition what we have seen. So here n is greater than m. So in the operation we are giving parameter as n m. For n there is t and s, or it will return 1 or 2 based on the condition what we have discussed, and we will print it. Else if here m is greater than n, then we will call the same function, but here m is greater than n, so we will just adjust our parameter. Here m is greater than n, and here t size of t is greater than s, and based on this we will check our operation for 1 or 2, and what it will give 1 or 2 we will print it. So let's discuss about each possible function, and it will give 1 or 2, so we are give return as integer, and here is n, m, s, and t, and here n is greater than equal to m. So our formula is length of longest common substring plus on left plus length of longest common substring on right should be greater than equal to, here m is smaller, the length of a smaller substring, length of a smaller string, sorry. So we have to find first the length of longest common substring on left, so we have to traverse it. So for traversing there are two strings, so let take index I and j for traversing it, and we store our length left, which is common in both string. So we will traverse from left side. So we will traverse till the smallest, till any of the string will get exhaust, and we will check that this string character of this string are equal or not. If it is equal, then we will increase our length that is common to both string. So length left plus plus we are increasing in. Else any case if it is not matching, then we will break out the loop.
The iteration we are implementing I and j.
On every iteration, we are incrementing I and j. Now we have to find the length of a longest common substring from the right. For this, we will traverse from the right side. So take index equal to n minus 1, right common index, m minus 1, length, right equal to 0, and we will traverse it. While any of these string get exhausted, now we will check if the character is matching or not. If it character match, then we will increment length right by 1. Else, if it is not matching, then we will break out the loop. On every iteration, we will going right side, so we will left side, so we will decreasing it. Now we will get our length, left length on right length, which is common in both string. Now we'll apply our main logic, that is length left plus length right. We will check it is equal to the small length of a small substring, and in this it is m. If this is if this condition satisfied, then we will return 1. Else, we will return the max operation it can do, and that it is 2. So now let us consider about the time and space complexity. Time complexity. For time complexity, let's discuss, let's see the code that in this we are inputting t. For each test case, what we are doing, this operation will take order of n, order 1, that is constant. This is also taking order of n, and we are in this we are seeing 1. In this we are seeing that in this either this will execute or this is executed. So we will consider about each possible time complexity. So let's see each possible time complexity. What is it? So we are looping our string. So this loop will go minimum of n or m. Why? Because if any of the string got exhausted, then our loop is break out. So in this, the time complexity is minimum of order of minimum of n into m.
Say in this case, m is always less in the function, right?
Yeah.
In that function specific, it would be m,
and
but the overall function specific, it would
or
be
in this m, in this m is always less than equal to n, so it will be order of m. Or in this also it will be order of m, because smallest substring is of a length m. So in each possible function, in each possible function, the time complexity is 2 into order of m. So overall time complexity is test cases into 2 into order of m. So the time complexity will be 2 into m, where m is a length of a smallest string. Now discuss the space complexity. So let's analyze our pseudocode. So in this pseudocode, we are taking string s on t, but we can't do anything because it is given to us. We are not taking any extra spaces or data structure. We are not using any extra data structure. So overall, our space complexity is order of 1.